Hi, my name is Vinh Nguyen, and I'm a graduate student at Purdue University working under parent tutor. My CV and list of publications can be found on my website. My main area of research is in commutative algebra. I'm specifically interested in multiplicity theory and determinantal ideals. Commutative algebra is the study of Noetherian rings and their modules. It is closely related to algebraic geometry. Algebraic geometry is a study of varieties, which are solution sets of polynomial equations. These equations form an ideal in a Noetherian ring. Hence, studying the properties of these ideals and rings sheds light on the structure of the variety. There are two important variants of ideals and rings. The first is multiplicity, which in some sense measures the singularity of the variety. The smallest multiplicity a variety can have is 1, and in which case it is smooth. So in some sense, the bigger the multiplicity, the further away it is from being smooth. The height of an ideal measures the size of the corresponding variety. The larger the height, the smaller the variety. And now I'll briefly talk about my two research topics. The Hilbert-Samuel multiplicity is a classic and well-studied invariant of ideals in Noetherian local rings. There are various generalizations of the Hilbert-Samuel multiplicity. I'm concerned with the following generalizations. The Book-Swan-Rim multiplicity is a generalization to modules of finite colength. Mixed multiplicity is a generalization to multiple ideals of finite colength. And finally, the J multiplicity and epsilon multiplicity is a generalization to ideals and modules of not necessarily finite colength. Within multiplicity theory, I'm mainly focused on Letsch's inequality. Letsch's inequality is an upper bound for the Hilbert-Samuel multiplicity of ideals. In joint work with Kelsey Walters, we were able to generalize Letsch's inequality to the Book-Swan-Rim multiplicity to mixed multiplicity. This result was published in a paper by the Proceedings of the AMS. In the case of the J multiplicity and epsilon multiplicity, a Letsch bound is still an open question, and I'm still pursuing this problem. As for determinantal ideals, I'm mainly interested in generalizing the Egan-Northcott bound for the heights of ideals of minors of matrices. The heights of the ideals of minors, an upper bound for the heights of ideals of minors can be improved if we know more information about the matrix. For instance, if we're given information about the rank, then a better bound can be made. And this bound was done by Bruns. We can also try to bound the heights of ideals of minors for certain types of matrices, such as alternating matrices and symmetric matrices. In joint work with Hunter Simper, we're able to provide an upper bound for the heights of minors of alternating matrices given their rank. The case of symmetric matrices is a conjecture by Eisenbud, Hunicke, and Ulrich. We managed to work out a couple of specific cases for symmetric matrices. Related to the topic of determinantal ideal is that of generalized upper triangular matrices, which I'll abbreviate as gut matrices. Gut matrices have a lattice shape of zeros in top right and bottom left corner. Ordinary upper triangular matrices are square gut matrices where the ladder in the bottom left is a triangle and there's no ladder of zeros in the top right corner. Also in joint work with Hunter Simper, we managed to compute the height and multiplicity for generic gut matrices. We were also able to characterize the configuration of ladders that yield Kolmogorov ideals. And that's it for my research. Thank you for watching.